Well, so far we discussed a lot about the electric power, but we did not talk much about the electric energy. This is the topic now. Let us consider this electric bulb. It is rated 100 watt 220 volt and it is connected to 220 volt supply. What so far we learned that if this bulb is rated at 220 volt and if it is connected to 220 volt, then it will consume this much power. It is 100 watt here. So this bulb is consuming 100 watt. That means 100 watt means it is consuming 100 joule in 1 second. So this bulb is consuming the bulb is consuming 100 watt. That means 100 is consuming 100 joules per second. Okay, now suppose I will say that this bulb will kept on and that is for 10 hours, then how much energy it will consume, that we will calculate here. So the energy consumption in 10 hours, that it is W. Okay, so W is equal to how much in 1 second it is consuming 100 joule, or W is equal to 100, it is consuming 100 joules per second. So 100 joules per second, it will be multiplied with 10 hours. That means it will be converted to seconds. So 10 hours converted to seconds, 10 hours converted to seconds, it will be multiplied with 60 and again 60. This will be in minutes and again multiplied with 60 will be in seconds. So this much seconds we can cancel S. So we get W is equal to 100 into 10 into this is 3600. So this much joules. Okay, W is equal to how much we get, 36 multiplied with, so you can write like this. So this much joules. Now we can write this as W is equal to 3.6 into 10 to the power how much, 6 joules, or we can write W is equal to 3.6 mj. Mj is megajoule. Okay, so this bulb is consuming 3.6 megajoules. Okay, this figure you see, this is a very big figure. This bulb, only a 100 watt bulb, and it is used for 10 hours and it is consuming this much, this big figure, that is 3.6 megajoules. Okay, this is a very large number. So in the household you can see many bulbs and heaters are there and geysers, there may be geysers or air conditioners. Those are high power consuming items. Suppose one electric heater that may consume 1000 watt or 1500 watt, and one air conditioner that may consume 1500 watt or 2000 watt, like that. And those figures, if we will consider their power consumption, then it will be even larger figure. That is also for 10 hours, if it will be kept on for 10 hours per day. So this will be the consumption per day, and if it will be multiplied with 30, then it will give the power consumption in 1 month, 30 or 31, whatever may be. So that will give the power consumption in 1 month, and it will be a very large figure. So handling this very large figure is not actually very convenient. That's why some other unit is used, that is watt hour, that we can use, or kilowatt hour, and this will be even more convenient. That is what we will go through. Let us discuss this. I will erase this. I have erased that, and if you want to repair that, then you can go back in the video and watch it again. So this bulb is consuming 100 watt. Instead of writing it in joules, let it remain in watt. So we know that P, that is the power of this bulb, is 100 watts. So P is equal to 100 watt. Now what is the energy consumed? Energy consumed, let us take energy consumed as U here. Okay, so U is equal to power into time. Okay, so energy consumed is the power multiplied with time, or power that what we know is equal to the energy consumed divided by time. So how we can get the energy? That is equal to power consumed is 100 watt here, 100 watt, okay, into T. Suppose this bulb, it will be add on for 10 hours, just like the previous case. Okay, so energy consumed will be 100 watt into 10 hours. So you get energy that is equal to 100 into 10, that is equal to 1000 watt hour. This is the new unit of the energy. This is used by the utilities also. Okay, now if we'll divide this by 1000, so it will become kilowatt hour. So you can write U is equal to 1000 divided by 1000 kilowatt hour. So this is the energy consumption in kilowatt hour. So U is equal to 1 kilowatt hour. So you can see that this number has become smaller and it is easier to handle, and this calculation is also simple. If it will be 60 watt bulb, then how much energy it will consume if it will be made on for 10 hours. So it will be 60 watt into 10 hours. So this much watt hour will be the energy consumption in 10 hours. And if it will be divided by 1000, so we'll get how much? This will be cancelled, so it will be 0.6 kilowatt hour. Okay, so this will be a very small figure, and multiplied with 30 will get the energy consumption for 30 days. You can see that this figure has become very small. So the utilities, they find it convenient to use this unit, kilowatt hour. So if it will be a 1000 watt heater and it will be used for 2 hours, so how much energy it will consume for 2 hours? So it will be, this will be multiplied with 2, so we will get 2000 watt hour. And if we will divide by 1000, we will get how much? It will be 2 kilowatt hour. Okay, this is the figure that we get for a electric heater. Similarly, for others you can calculate, and it will be easier. That's all for now, and we'll discuss more later.